Hello everyone. In this video I'm going to be talking about batteries. I'm going to try and cover most of the basics that you need to know to use batteries in your application. A lot of this video is going to be very much focused towards combat robotics since that is my audience, but a lot of this information is going to be universal for anyone using batteries in applications from robotics to RC to hobbies, things like that. So let's get started and talk about different types of batteries and different battery chemistries. So before we get started, I did want to mention that in this video I'm going to be saying generally speaking a lot because this information is generalized and it's more to give you just kind of a basic understanding of some of these concepts. There of course will be exceptions and other use cases and things like that. So talking about battery chemistry, in front of me I have several different types of batteries, and these are things that you might be using in your applications. Primarily a lot of the stuff here is going to be lithium polymer or LiPo or LiPoly, I've heard it called. That is one chemistry that is probably the most common. If you're going to buy a battery on eBay or Amazon or Hobby King, something like that, most likely it's going to be a lithium polymer or a LiPo battery. There are other variants of lithium batteries. We also have, I think this is a Life battery, which is a lithium iron phosphate. And then I do have some lithium ion batteries here. These are typically going to be a hard shell battery. They're used in different applications, but for the hobbyist, you're generally going to be using a LiPo. Now over on this end, you might see some good old classic NIM batteries. NIM is nickel metal hydride. I don't have any NiCads here, but that is another type of rechargeable battery. These are largely out of fashion right now. They just don't have the discharge rate, they don't have the power density, and if you're using any type of these batteries for combat robots or other robotics applications, you might either A, have a very specific reason for doing so, or you might be outclassed. If you're using these in a combat robot situation, you're probably not going to have the current delivery. They're going to be way too heavy. They just don't have the power density and the current delivery of the new modern lithium batteries. The different types of battery chemistries have a multitude of different characteristics to them. We could talk about how many times a certain battery likes to be charged and recharged and discharged, and how long it can be discharged for and what the charging profile looks like and all that good stuff, but that is beyond the scope of the video. But what we are going to talk about is how the chemistry affects our use of them. For instance, a LiPo battery has a nominal voltage of 3.7 volts. That means that each cell inside of this battery is 3.7 volts nominally. Nominally basically means that is just kind of the baseline level of the voltage. It can go up and it can go down from there. A fully charged single cell LiPo is going to be 4.2 volts, and I think fully discharged it's like 3.2, 3.3, something like that. A Life battery, the nominal voltage is about 3.3, so a little bit lower. Lithium ion, 3.7, and then your NIMs and NiCads are going to be about 1.2 volts. So how do we get a battery that is like 24 or 26 volts? Well, each one of these is made up of individual cells. So by taking those individual cells and running them in series, plus to minus, plus to minus, plus to minus, we can get different voltages out of them. So let's take a closer look at cell voltages and discharge rates and all that good stuff. I have a variety of different battery packs in front of me, and all of these batteries here are made up of several individual cells wired together in series to get various different voltages. Now, a battery is going to have basically three ratings. It's going to have the capacity, which you can see in these big numbers here on the front, and then it's also going to have an S rating and then also a C rating. The S rating is going to tell you how many cells are inside each battery. This is a 3S battery, and if we look inside, we can see 1, 2, 3 individual cells. I like this one because you can clearly see the individual cells wired in series. And if we look at the label, we can see it's an 11.1 volt. 11.1 divided by 3 is 3.7. 3.7 is the nominal voltage for each one of these cells. Now, if we look at one of these bigger batteries, this is a 6S, and that gives us 22.2. 22.2 divided by 6 is 3.7 volts, so there's 6 individual cells inside this battery. So now we know that the S rating corresponds to how many cells are in the battery. What is the capacity rating that we see on all of these? We got 5.0, 3.0, 1.5, 400 milliamp hour. What do these numbers mean? Well, that is just simply the capacity, how much juice is inside of one of these. So if we look at this big one, it is a 5.0, and you see maybe in smaller writing here, 5,000 milliamp hour. That basically means that if you had a 5 amp load on this, if you were drawing or pushing 5 amps worth of current out of this battery, it could last for 1 hour doing that. You will see it in amps or milliamps. Milli is 1,000th of an amp, so 5,000 milliamp hours is the same as saying 5 amp hours. Typically, a smaller battery is going to be rated in amp or milliamp hours, but it's all over the board. This smaller one is rated in 1.0, which is 1,000 milliamp hour, and of course this little guy is only 400 milliamp hour. So if we look at this, we can say that it can deliver 400 milliamps worth of current for an hour, or you can simply do the math. It's not perfectly linear, but if we had a half an hour, we could do 800 milliamps over that whole time. Or if we had 15 minutes, we could do 1.6 amps. So that begs the question, we know the capacity, we know the voltage, what is the peak amount of current that these batteries can deliver? Well, that's the C rating. For most robotics applications and combat robots, definitely you're going to want to pay attention to the C rating of the battery. The C rating is going to tell you just how much current your battery is going to be able to provide the rest of your electronics. All these batteries have very different C ratings, but they're all calculated the exact same way. So if we look at this big battery, it has a 75C discharge rating, and that just means that 75 times the capacity, which is 5, is going to be the maximum amount of current or amps that this battery can provide your electronics. 75 times 5 is 375, so that means this battery can produce 375 amps worth of current. It can do that instantaneously. It's not going to be able to do that for an extremely long time, but that is the maximum current that this battery can provide. All of these batteries are going to have different ratings. They're going to range anywhere from 20C all the way up to 75. You may see some batteries with a peak rating of 100 or more, but about 100 is going to be about your max, and 20 is going to be on the very low side. If you're doing the math in your head, you're going to realize that the higher the capacity of the battery, the more discharge you're going to have, the more current you're going to be able to provide, because it's always the discharge rate, the C rating, multiplied by the capacity. So generally speaking, the bigger the battery, the more current you're going to be able to provide. So now that you have a perfect understanding of the S rating, the C rating, capacity, cells, and all that good stuff, now you needed to connect it into something. So let's talk about the connectors. This is a pretty good sampling of all the connectors that you're going to encounter with batteries. Over here, I'm going to start with this little guy. That red connector right there, that one, is a JST RCY connector. JST is actually not a type of connector, it is actually the manufacturer or the brand behind it. So that is what that connector looks like, and this is really only going to be useful for your smallest robots. Think of like 150 gram, the ferry weight, I guess, and then a US ant weight 1 pound. Anything beyond that, you're just going to run into current limitations with that connector. I'll talk about these in a second. Then you're going to be moving up into the XT connectors, and you have a couple different varieties here. Don't mind the different colors of these. They're effectively the same connector. You have an XT60, or I'm sorry, XT30, which is this little guy, XT60, and an XT90, and this is also an XT60. XT30s are going to be good for like your 3-pound robots, and probably that's about it, or maybe drive applications in bigger bots. The XT30 can definitely be used in a 3-pound or maybe even up to a 12-pound bot, and then the XT90 is going to be pretty much in all of your bots and bigger. For the really big bots, you might even want to re-terminate this with a different connector. So that leads us to these little connectors that are hanging off of all the batteries. What are these guys? Well, these are the balanced charge leads, and we'll get to that in a second when we talk about the charger. And the thing that you'll notice is there is one more wire for however many cells there are. So this is a 3-cell battery, and we have 1, 2, 3, 4 wires. This is a 6-cell, and we're going to have 7 wires. These are basically wired into each one of the individual cells. These use a JST-XH connector if you want to extend these. These are not really used for power delivery. They're only useful for charging, but sometimes you might want to extend these out just to make it easier to get a bunch of these batteries into the charger. So once again, these are a JST-XH connector, and they can come in any number of different pin configurations, anywhere from 2 all the way up to 10 or 12 or whatever. So now we need to actually charge the batteries, and there are specific chargers for LiPo batteries. Of course there is. Why couldn't it be easy? So I've got a couple chargers in front of me, and there's a couple things that you need to look out for when choosing a charger. They can be pretty inexpensive and pretty simple, so let me run it through. The biggest thing that you need to pay attention to is it going to be able to charge the battery that you have? If you have a 25-cell battery or something like that, you might need to get a specialized charger. But generally, if you're in the 2 to 6 or 8-cell range, most chargers are going to be able to handle that. Right on the front of them and in the description, it's going to tell you this can handle 1 to 6 cell. It's going to do NIM, NiCad, lead acid, all that good stuff. And the other thing that you're going to need to look for is the charge rate. How much power are you going to be able to put into the battery? We'll get into that in a second, but generally speaking, you're going to want to charge the battery at 1C. So basically 1 times the capacity in amps. So this big one, we're going to want to charge this at a rate of 5 amps. And then this smaller one over here, 1.5. So you're going to push 1.5 amps into it. And depending on the voltage of the battery, that is going to ultimately determine how much wattage or how much power you're going to be pushing into the battery to charge it. That is the first factor. The second factor, you see these two chargers look nearly identical to one another. The biggest difference is this one has a built-in power supply. This one does not. Most battery chargers do not have any power supply whatsoever. So you're going to need to supply an external power supply to this that either plugs into the wall or, get this, is going to be battery powered to charge your, you guessed it, batteries. So be sure to be on the lookout for that. Some people like the ones without a power supply. I'm not really a big fan. I kind of like the all-in-ones. There are also chargers that can charge multiple batteries at a time, all sorts of stuff like that. I actually just have this really cheap one, plugs into the wall, charges 1 battery at a time, always worked out fine for me, and I just have this other one as a backup. The next thing that you might want to look at is one of these cell voltage monitor things. It is a very simple little device. I think there's a $15 or $20, and you can take the balance cable, plug it directly into the side of this, and I'm not sure if you're going to be able to see that, but it'll give you the voltage and the capacity. So right now we're at 79% of a charge and 16.07, and we can even use these buttons to look at each individual cell voltage. So something like this is extremely handy because you're at a competition, you're doing whatever, you throw all your batteries into your toolbox, and you need to know what the charge is. So something like this is a very handy tool to have. So I wanted to do a very quick walkthrough on how to charge a battery. There's a lot of settings and a lot of stuff going on in these chargers. Thankfully, almost every single interface is nearly identical between all the chargers I've used. So from this main screen, you can select all your different types of batteries. You got life, LiLo, high voltage, NIMs, NiCads, all that. Since this is a LiPo battery, we're going to go ahead and go to LiPo. We're going to hit enter, and you see we have a couple different selections. We've got balance, we've got discharge, we've got storage, fast charge, things like that. We are going to be doing a balance charge. So a battery typically does not like to be stored at its maximum voltage, and it also doesn't like to be stored when it's fully dead, so that is why you have the storage. So you would just plug this in and charge it, but you would do the storage and it would bring it down to the appropriate level. So let's talk about connectors. On the side of here, we've got a couple banana plugs and then all of the balance charge ports. With these chargers, you're generally going to get a lot of cables. So it's going to be a banana cable that goes into there, black to black, red to red, and then it's going to be terminated with a Dean's connector. This is what a Dean's connector looks like. And then you're going to have a bunch of mating ones that go to your battery. So you got an XT60, I've got an XT90, I've got the one of the RCYs that we talked about. It's going to come with all of these. So you just simply plug that in. It's keyed, so you can't get it wrong. We're going to plug this side into the battery, And then we're going to plug the balance leads into the corresponding balance leads on the charger. And that's pretty much all there is to the connection side. So you can see where you might want this to be a little bit longer if you have a really big battery or a big battery pack. So from here, we've got a few settings. We're just going to hit enter. And now we can change the charge current, and we can also change the voltage, which is how many cells the battery is. Earlier, I said that I always charge at 1C. That is generally the best way to do it. This does not damage the battery. It does not ruin the life cycle of it. You can certainly charge a lot higher if you want, if you're in a time crunch. But honestly, if you're in a time crunch and you just have to get the battery charged, just make sure you have a spare battery. I always have about 3 batteries just so that I don't run into that situation. But you can charge a lot higher. You will degrade the life of the battery by doing so. So I always charge at 1C. So that is 1.5. Since this is a 1.5 amp hour battery, we're going to hit enter. And then here you can select how many cells the battery is. This one is a, what is this? This is a 4 cell. So we're going to go up to 4 cell, and then you just click and hold. It's going to check the polarity and make sure that there's something plugged into here. And then we just hit enter, and it's as simple as that. It will start charging, and you can even use the left and the right to actually view the cell voltages. We've got 1, 2, 3, 4 cells, and they're all right around 4 volts. And if we go through, we can see that the battery is at 87%. It's not going to tell you how much time is left, but it will give you some other little stats like that. So it's really that easy to charge a battery. So the last thing I want to talk about is safety. LiPo batteries are inherently pretty dangerous things. If you think about combat robots or robots in general, think about like an RC car. Think about what those things can do. Think about how fast an RC car can drive, or think about a combat robot, you know, how much they can smash and hit. All of that energy was at one time contained within one of these little batteries. And here is a nice example of one that is super puffy and nasty. I'll get a closer shot of that. And then here is one that has a little nick in it. And as you can see, I am handling these very, very delicately because lithium batteries, LiPos in general, are pretty delicate things. Any kind of puncture or any kind of impact can cause them to rupture. And once they burst open into the air, it's just like this chemical chain reaction and things get really nasty, as you can see from something like this. So, general safety. You should always charge inside a LiPo bag. I always charge very safely, therefore I don't have a LiPo bag. I am not claiming that this is the best way to do it. It is just kind of my practice. I always charge attended. I am always out here when it is charging. Sometimes I even charge on the concrete. I do not use any battery that has any compromises whatsoever, like this one that has a little cut in it. I will not use this. This is just for demonstration purposes. If you have a battery that has any puffiness to it or has like air or gas inside of it, if it's not solid, don't charge that battery, toss it. And when I say toss it, make sure that you dispose of these responsibly and properly. Usually at robot combat events, there is going to be some bin specifically for LiPo batteries, or check with your local county or city for the proper way to dispose of LiPo batteries. But please, absolutely do not just toss these into the trash, because if they get compressed, they will set on fire and it could, well, literally create a dumpster fire. So be mindful of that. Don't try and charge batteries that have any issues with them, whether it's puffiness, whether a little bit of break in it, or you know, whatever this is going on. You can get LiPo bags, as I said earlier, which is basically a fireproof bag that you can put the LiPo batteries inside of to either transport or charge or store, whatever. That is generally a good idea. They're pretty cheap. Get them on Amazon. I should probably get a couple. And I think that's all there is to know. I think the last thing is LiPo batteries, which is the lithium iron phosphate, are basically a much more stable version of the standard LiPos. So if you have children or if you're doing robotics with kids, you might want to look at LiPo batteries. They have a significantly lower discharge rate, so they can't provide the current delivery. They don't have the current density as a traditional LiPo does, but they are a lot more stable and a lot more safe. This is, to my knowledge, the only lithium battery that can and legally will be used in like kids' toys, things like that. So LiPo batteries are going to be a lot more stable. And if, let's say you have a robot that has issues with battery fires a lot, and maybe you want to look at a LiPo battery instead of a LiPo. So hopefully you have a much better understanding about LiPo batteries in general. Hopefully you now know what the C rating is, the S rating, the capacity, and all that other stuff, and you can use that knowledge to calculate the appropriate size battery for your application. There is, of course, more to talk about on this topic, and judging on the interest in this video, I might end up doing like an advanced battery tutorial, because you can certainly create custom battery packs by wiring things in series and parallel, and you can start using individual cells to get the exact battery that you need. For instance, what I did for Lolo Man, I needed a very slim battery, so I created my own pack. Also, like a lot of advanced charging techniques, you will not always be in a situation where every single cell in the battery is exactly the right voltage. You might need to kind of tweak that a little bit. Sometimes cells die and you might need to jump them back to life. So let me know if you're interested in kind of the advanced battery tutorial, but hopefully this gives you everything you need to know to start with combat robots and other robotics in terms of knowing how the batteries work and how to use them. Thanks for watching. Be sure to check me out on Facebook for any updates, and thanks for watching. See you next time.
2, 1, fight, robots. Both robots up to speed very quickly. This is going to be a heck of a first hit. Huge sparks flying.
What a hit!
And Flycatcher has just exploded.
That's a tap out.
We have a tap out and we have a battery
And
fire.
we got smoke!